Hello, Math 1052 students. I'm going to do question number 3 from Lab 7. This is calculating profit or loss from overhead expense as a percentage of selling price, profit as a percentage of selling price, and markdown rate. Okay, this is the procedure essentially that you use if you see numbers as a percentage of selling price, such as E and P or even M, and you only see the cost, which is 491 in this case, and the markdown rate as well. If you see percentages as a markup on cost, there's a different procedure, and I'll explain that in another video lesson. Okay, so let's look at the question. A store in Vancouver has operating expenses of 10% of the selling price and operating profit of 20% of the selling price. During a sale, their watches were marked down by 20%. What is the profit or loss at the sale price if they purchase the watches at $491 each? Okay, now let's fill up the merchandising table first with all of the given information first, and then fill up the table, and then we'll try to answer the question. Okay, so what do we know? We know that the operating expenses, or E, is 10% of the selling price. Okay, so we have to fill up this E row here. We can't fill up the amount as a dollar value because we're only given a rate of E as a percentage on selling price. So we'll fill that out first. So operating expenses is 10% on the selling price. So E, 10% on the selling price, goes under here. If it was cost, it would go under here, but now it's on selling price. We also know that profit is 20% of the selling price. So P, can't put a dollar value amount here. We're only given a rate of profit on selling price. So 20% goes up here. Right. The other thing we're given, the other two things are given are markdown and the cost down here. So markdown rate is 20%. So markdown, can't put a dollar value, we're only given a rate. Okay, so markdown is always over the selling price, or markdown on selling price. So that'll be 20% up here, down here rather. The last thing we are given is the cost. We're told that they purchased the watches at $491 each. They being the owners of the retail store in Vancouver, the watch store. So $491 will be cost. So we put that in as a positive value up here, and as a component of the selling price. And a negative value is a component of reduced profit. Okay, negative 491. Okay, so these are all the givens that are provided by the question or by the business situation. We are not given any other dollar value, right? So we cannot fill up the boxes with dollar values on the beginning. What we need to do is we need to use algebra and fill in the boxes as algebraic terms or algebra terms. All right, let's start with the overhead expense. We know that overhead expense is 10% of the selling price, right? 10% on selling price. So we can create an algebraic expression for that. That is E equals 0.1. This is the decimal form of 10%. Multiplied by selling price, because that's what it means. It means overhead expense is 10% of the selling price. So that translates algebraically as follows. E equals 0.1 S. S for the selling price. We can do the same for the profit up here. Okay? So here, we create another algebraic expression. P equals 20%. This is the decimal form of 20% of the selling price. That's what this means. Operating profit is 20% of the selling price. So 20% of S for the selling price. Okay. Now, since we don't know what the dollar value is, we plug in the algebraic terms for P and E in the P and E boxes. Right? So start with the E. 0.1s goes in this box, 0.1s. And the P, 0.2s, also goes in the P box, 0.2s. This is the procedure every time you see components of the selling price as percentages of selling price. If you see it as percentage of cost, there's a different procedure. Okay, now we can still proceed and fill up the rest of the boxes in the table. Right, so M, M is P plus E, so we add these two algebraic terms. So that would be 0.2s plus 0.1s to get the markup in algebraic terms. All right, the secret here is that S, right, also can be, we can also fill the box with an algebraic term. S, to fill up the S box here, is always S. Right? And remember, if you have just S as a variable, there's always an implied 1 as the leading coefficient or the number beside S. So it's 1 multiplied by S. Right. So now, since we know M plus C is S according to the table, we now have the basis for an algebraic equation. Okay? So here, right? So this is M plus C equals S. Now I can plug in what M is, and we know it to be 0.2S plus 0.1S, right? I know what the C is, right? The C is $491. So I simply add that plus 491 equals S. And S, look at the box, it's 1S. So 1S. Okay, now I simply I have an algebraic expression with just one variable for S, or selling price. I can use the magic of algebra to actually isolate S and get the exact dollar value of the selling price. It's great. Okay, so I simplify this, 0.1S, 0.3S rather, plus 491, this is a 3, sorry for the mistake, 0.3s plus 491 equals 1s. I'm going to put all the variables to one side of the equation, all the constants to the other side. Okay, so I'm going to move this 1s to this side and the 491 to the other side. Every time I do that, they change signs from positive to negative. Okay, so that'll be 0.3s that goes down. This 1s becomes negative 1s. This 491 becomes negative 491. Okay? Now, simplify this. 0.3s minus 1s equals negative 0.7s equals negative 491. Right? I know this because every time I add two algebraic terms with the same value, I add, or in this case subtract, the two leading constants, 0.3 minus 1. That'll be negative 0.7. Okay, now I need to isolate S. To do that, I divide both sides by negative 0.7. Okay, this will cancel out. S will be isolated, and I just use calculator to get that number. Okay, turn that on. Press this to make it negative. All right, this is going to be a negative number, 491 divided by negative 0.7, and I get 701.43. Okay, I'm rounding off to the nearest second decimal place. That is the selling price, 701.43. Okay, go back to the table. I can fill the S box now with a dollar value, 701.43. Okay, and I can continue to fill up the merchandising calculation table. Now, since I've got the S, I can calculate the markdown, the dollar value of the markdown. Okay, so I'm just going to go back here. So I know that the markdown rate is 20%. So this is always a percentage of the selling price, and I now know the selling price. So that'll be D equals 0.1, 20% decimal form, and I plug in the S here. It'll be S, so 0.2, and I plug in the 701.43. Okay, the calculator here. 701.43 times 0.2. Excuse me. 701.43 times 0.2. That will be D will equal to 140.29. Okay. Go back to here. Now I can fill up what D is. Put a dollar value there as well. 140.29. All right. A reduced profit will be the selling price minus the dollar value of the discount. Get the calculator up. All right. So I get 701.43 minus 140.29. Then I get the reduced selling price, rather, not the profit, reduced selling price will be 561.14. Okay, so I'm moving along. Now I can continue. I need to figure out what the reduced profit will be, but the E box here is still empty, right? I need to put a dollar value here. And now with all this information, I can put a dollar value. I don't have to put a algebraic term anymore. All right, so I go back to the E box. I know E is 10% of selling price, and I already know what selling price is. So I go back to the E equation up here, right?